And we're live. What's up, everybody? Welcome to the pre-show. We're going to start the full show in just under 5 minutes or so. So if you're in the chat room, say hello. We'll shout you out as the stream gets strum. So I got to wait for Facebook to go fetch the stream. This can take a few seconds. There it is.
We are now live. Good morning, everybody.
I've never seen this this warning. It says, do not put third-party video ads in your live video. For example, do not include bumpers, pre-roll, mid-roll, or post-roll.
How do they know?
I don't know. They're just telling you. We don't know, so this is just Facebook. Okay, ready to go live on Facebook?
Yes.
Okay, here we go. Good morning, everybody in Facebook. We are live streaming today. Welcome to the pre-show. We'll start the full show in just under 5 minutes or so.
Quick shout outs to everybody in the chat rooms. Hello, Tech Guy 12.
Hello, how are you
Jim
doing?
is in the house. We got ZZ9PA. Juba is first time watching. Welcome.
Welcome, first time caller.
Sparsh made some Firewalker sneakers. Very cool.
What's going on, guys? We're about to do the show. We are very excited to share this week's project and next week's project. Oh, you got the Snapticles. Yeah, we are loving the Snapticles. It's actually our kind of our tool for this week's shop talk. We're going to talk about the Snapchats and how we're using them to capture some BTS work in progress stuff.
Some more shout outs over to Tech Graphics, Ahmed, Stuart Riggs. Got Blitz City DIY, Liz in the house.
Hey Liz, how you doing? Good morning.
Startup 3D.
John K, good morning to you, sir.
Hello, hello. Good morning, everybody.
Bear with our grouchy voices.
Kirby in the house.
How's our audio? Did we sound okay? We always have a problem with the audio, so that's why we do the pre-show. Conserving battery life.
Yeah.
Or does it have sleep dog, watch dog?
Hello, hello. Kamel Das on Facebook.
Oh, hey, yes. Stuart is saying, yes, Snapchat glasses are great for documenting. Yeah, that's what we're using them for. They are working out. Cool. I want to go grab them actually because they're charging right now. Good morning, Medable.
Shared here, shared there. Notes loaded.
We should be okay.
Why, thank you, Daryl Tech Tips. Thunderbolt Tech. Hello, hello, good morning.
Good morning, everybody in Facebook. And Periscope and Twitch and YouTube.
Stefan
Thank you
is
for joining us today.
asking if you need glasses. Well, these are prescription glasses.
Yes.
Or lenses.
I would go grab my own, but we're about to start the show. It's up to you, Pedro, to show them. You have no choice. They're prescription lenses. You can't see without them. All right, you ready to start the show?
Let's start.
I kind of want to warm up my coffee, man. Need a warmer. Good morning from South Louisiana. This is Cajun. Thunderbolt Tech in the chat room. Hello.
Storig's got some prescription lenses.
Facebook, Alex Hatch has joined us. Hello, Alex.
Yo.
Happy 2018 to you, sir. Hope you're doing well. I am making sure my tabs are all laid out properly.
I think I got all my notes.
Okay. Lots of warnings here in the restream, but that's the way it is. Cool, we're going to start the show, guys. A little bit early, but hey, we're ready. You ready?
Yep.
Here we go. Hey, what's up everybody? Welcome back to another 3D Hangouts. I'm Noé, a designer here at Adafruit, and joining me every week is Mr. Pedro.
What's going on, everybody? I'm Pedro's Creative Tech here at Adafruit, and every week we come to share 3D printed projects featuring electronics from Adafruit.
That's right, this is where we combine 3D printing and DIY electronics, we smash them together and make physics.
For this week's project.
Yeah. How's everybody doing today? Thank you so much for joining us. This is episode number 168. And let's go ahead and start off with paying some bills, because we tend to do that here, with a coupon code, Gravity.
That's right. This week's coupon code is Gravity. Get 10% off when you use Gravity during checkout at the Adafruit shop. Got lots of freebie goodies still going on.
And things are back in stock. Lots of things are back in stock, including all the things that were used in today's project. We got some freebies still going on. This is, oops, that's the outdated image. I need to overdo that. So if you go to adafruit.com/free.
A good opportunity to share this URL.
We now have three things. So there's 3 different tiers. Spend $100 or more, you get free Adafruit promo proto half-size breadboard. $200 more, you get free UPS ground shipping. $300 or more, you get Adafruit Circuit Playground Express plus the other 2 things. Pretty good deals. Again, go to adafruit.com/free for all the details and more on the deals. We still have same-day delivery for the fine folks in Manhattan. There's certain area codes that this works, so check out Adafruit site for more if you want same-day delivery. Daily news is Adafruit newsletter, one of which you have to subscribe to. So there's different categories like biohacking, circuit Python, 3D printing, and more. We have a new newsletter, adafruit.com/newsletter. This one is more about the product, so if you just want to know about the products, you can check that out. That is once a week. The daily is, well, it's daily. Discord chat room. We have a Discord channel. We have about 3,000 members in it now, so if you're looking for project help, you're looking to share your projects, you're looking for the community to kind of get inspiration and that sort of stuff, you can chat along with us. This is a chat that doesn't go away. It's up there forever, as long as we're alive.
24/7 chat help. Everybody hanging out.
And we also have badges and stuff, and you can win all sorts of stickers and interesting things.
Exclusive pins you can only get from being in the Discord.
That's right. So you can join us by going to the link. It's actually at the top of the YouTube chat here, discord.gg/Adafruit. All right, let's start off with this week's project. Very fun one. Very gravitocious. You like that one?
Yeah, this is a super fun little physics toy. This was inspired by a really cool post. I believe I first saw it.
Oh, you want to go through that real quick?
Rome.
Yes, let's give out some credits here. So this was done
Some
by
background.
Yeah, some background. Thank you. So we saw this from Caleb Craft. He posted this. This is a project from Mike's Electronic Stuff. He's pretty big. Check out his YouTube channel. A lot of great content and projects. So this is where we first kind of saw this type of project.
Yeah, so this was at Maker Faire Rome. It was showing off really cool physics, little LED. Looks like a cylinder.
Lots of LEDs in this one. Yeah, a cylindrical body with a ton of LEDs encased in some sort of acrylic or something. It looks really, really cool. So this got Lamar and Phil B interested in kind of replicating that and simulating their own using some of the parts that we have. And then recently, like 3 days ago, Reddit user ZZ Zorok posted his LED cube, which everybody's losing their head over, because this thing is insane. It's a 6-sided cube. This is his prototype. He's working on documenting and kind of publishing the project as an open source project with all the code and stuff. He's working on it. So that'll probably be out. So keep your eye on this space. You can find it on Reddit. And our version is published. It's ready to make. This is awesome. We kind of put this together in a couple weeks. And Pedro, tell us about it.
Yes, so it's using the Charlieplex feather wing on top of an M0 feather and the LIS 3DH to calculate all of the inputs to display some very nice simulated physics Philby notes that it's not real, but real enough to actually trick your eye with the collision detection, some bouncing that's going on in there. So if you go over to the overhead, you can take a look at what that looks like. It does a very good job of fake simulation, is what he calls it. I would say this is real simulation.
Yeah, I really like the way the pixels interact with each other. So there's a little bit of bounce to them. It's very, very bright. We kind of cranked the brightness all the way up, but we can crank it down. In the latest version of the code, it's a little bit lower, so it sort of saves
should
the
help
battery.
with battery. So originally came up with a wearable case for this, but he had a really good idea of making a dome enclosure out of this. This is actually a sphere that's been chopped up into the lid portion for the back here. And the cool thing about it, having a sphere dome back, is that you can let this teeter-totter back and forth, creating a very addictive.
Yeah, I wasn't sure how this was going to come about, because I wasn't so sure about printing a dome, but you figured it out.
Yeah, there's some overhang that the Ultimaker and most printers should be able to do a really good job of doing that. So there's absolutely no support material that was required for any of the parts in this. And
yeah,
this is going to be a hard show because it's so addictive to look at.
It's quite fun to play with. So it's just a handful of parts again. All the parts are in the shop. They should be in stock. We're using a 350 milliamp battery, so you get a good couple hours of play time.
Yeah, we're still on the overhead.
Yeah.
So Philby had that idea. You have access to the USB ports, the on and off switch, and then he also had the idea of having it inserted into a gimbal. So I edited the design for that. Actually had the idea, or I got the idea for the design from Make Design.
Yeah, Josh, he goes by Design Make Teach on all the social channels. He did a nice sort of, what would you call it, like a collection of different gimbal type designs. So we took a look at his design and said, yeah, that's totally doable. So you put this together in Fusion 360, did a couple iterations to get the tolerances right, to get the nubs and the dimples correct. And it's so free spinning that you can really kind of perpetuate the motion by just kind of shaking it back and forth a little bit. You know how gimbals work. So the weight too was something that just kind of worked out. We didn't plan and do calculations on how to make sure the gravity and the weight is all distributed properly.
Yeah, so the weight is handled by the amount of infill that's going into.
Okay, so there's a high infill count?
It's about 30%, which is pretty high.
Sure, yeah.
Considering that we print everything like 10% or 15%.
Right. It's printed flat down so that you know, as the printer gets up, it can resolve the top really, really good. Yeah. And it's just a regular 0.2 layer height.
A regular 0.2.
You don't need the super smooth or any finishing really to make it kind of bounce back and forth, teeter back and forth. It's pretty nice.
The gimbal little rings print with no supports as well, and you can either print them in place or print them separately, since they do a pretty good job of just being easily assembled by bending the little nubs to get into the little grooves on the inside there. Yeah,
so you can kind of like bend it a little bit by compressing the ring to allow the dimples to come in there.
Exactly.
But yeah, it's almost frictionless. It's pretty nice.
Yeah, it's
you don't really hear much grinding or anything. It's really nice how you did it.
Yeah, super fun. Again, it's
it's
hard to get through.
Yeah, it's pretty fun.
Not playing with it, but. Let's go ahead and jump into the guide.
Yeah, we're going to walk through the learning guide so you guys can get a feel of if this is an assembly that you can take on or not. I think it's definitely beginner friendly.
Definitely think so.
Yeah. Just a couple wired connections we'll go through. So all the parts are here. There's a add all button to your cart, and then you can remove anything you don't need, like maybe a printer and some filament, but we do offer those as well. So again, on the sidebar right here, add all to cart. So you can do that. All right, let's take a look at the circuit diagram. This is going to show you how the wired connections kind of look like. It's not to scale, it's just a kind of visual reference of where the connections are going to go. This is kind of freehand wired, so we're not using any of the headers, just because the mounting situation is very particular to where you want it the most slimmest as possible, so no headers here.
Yeah, so we had a 3D printed spacer that's acting as the header so that we could fit the 350 milliamp hour battery between the feather and the Charlie wing. Right. And then the LIS 3DH sits on top of the M0 Proto via a 3D printed mount.
Cool. All right, all of the connections are broken out in text format, so you can take a look at that if you want. But the visual recipe should be pretty good. Serial clock, the serial data, they're all nicely labeled on the side of the pinouts on the feather. So it's
and
pretty nice.
Because of that, there's only 4 connections needed for all 3 of the other boards. They are just using serial clock data, ground, and 3 volt for that. So there's really wasn't a need. Yeah, there really wasn't a need for having the header since you don't need all of those connections.
Cool. You can power everything off the 3 volt regulator, meaning that you can use the enable and ground to turn the whole 3 volt regulator on and off, and you can still recharge the battery because all feathers have built-in USB recharging, which is excellent. Hey, let's take.
I provide all of the required lengths for each connection as well, so you can get those all there as well.
That's very handy. Very, very handy. Let's talk about the code written by Philip Burgess. You can check it out. You will need a couple Arduino libraries for this. It's running off the LIS3DH Adafruit library and the CharliePlex LED Matrix library. You can check those out using the library manager in Arduino. One of the things you'll have to download manually is the Adafruit Unified Sensor. For whatever reason, that one's not showing through the library manager. So if you right-click on our link, you can download it off of GitHub. There is a clone or download. Just download the zip if you'd want and throw that folder in your Arduino library, wherever that resides. Here's a good look at the code. It's up on GitHub. You can contribute to it if you'd like, but it's pretty nice. It's a little bit flexible where you can change the height and the width of the pixels. Let's say you have like your own custom board or something. You can change the number of grains of sand. And you can, of course, step through the code and figure out exactly how we're poking through registers directly instead of kind of using the library, which is pretty awesome, just to kind of make it a lot more fast. Pretty awesome. It's fairly well documented, so if you are looking for some inspiration on how to do the math and stuff, it's all here. So check it out, and we welcome you to remix it. On to the 3D printing page. These are all the parts that you're going to need to make it. If you don't have a 3D printer and you want to order these parts, you can do so from our Thingiverse page. You can click on that. There is a button. We really don't talk about this much, so I might as well talk about it now. There is an order this printed. You see this button here? Order this printed. So you can actually order that from 3D Hubs and have a local maker hub 3D print it for you and ship you the parts, which is pretty awesome. So you can do that. There's lots of options here. If you do have a 3D printer, we do give you some slice settings, at least the ones that we use on our Ultimaker using Cura 3 point whatever, using PLA material. All that sort of stuff is pretty much there. There's not that much cleanup really required, really zero cleanup, but we just have a note there. If you do have some overhangs or something, you can clean them up. So that's the 3D printing section of it. Pretty straightforward. Grab the files. You could also download the Fusion 360 files. You can download it as a step file if you're using SolidWorks or Rhino or any one of those, or you can just download the STLs from the many repo sites. All right, on to the assembly. This is how you assemble it. Pedro, you want to take this?
Yes, so we are doing all the hookup with the silicone coated wire because of the ability for them to bend very easily without fraying or breaking. So you can get a whole spool of every different color for that to tell all the connections apart. Jump back into...
It's trying to answer questions.
I know. So I'm using the third helping hands just to help solder all of those connection points. You could 3D print a little holder for that as well. And then the slide switch assembly for this. This is what's going to enable you to turn the circuit on and off while still being able to recharge the battery. Simple little setup here. We're just hooking up ground and enable for that and cutting off the third pin for that. I'm going to give a shout out to this little kit of heat shrink tubes. We do have some in the shop, but the only thing I don't like about them is that they come in all these sizes. All of which I'm only going to use pretty much just these 3 sizes here, especially the little ones. The, what is it, the 1x45 millimeter sized ones. Now, you like using the red and the yellow ones.
Yeah, it's funny how it has like a bunch of them, but we only use 3 out of the whatever.
Yeah.
Yeah, you can pick this up on Amazon. It's just an assortment.
Definitely recommend it.
I like it, yeah.
For keeping those connections sealed when you insert them into the enclosure. And you can just use the side of your soldering iron to shrink those up as shown here.
Yeah, not the tip.
Yeah, don't use the tip. To wire up the boards, I held them in place with two other third helping hands, just because I'm going to be having all the connections soldered from the bottom of the board to make it easier to mount onto the 3D printed spacer. Reference all of the connections in the circuit diagram with the required lengths for all this, so they can easily have enough room to reach each other, and enough room so they can tuck in between with the battery when you assemble these together. The slide switch is soldered on top of the featherboard. So you are going to be doing multiple connections for each pin. There should be just enough room for the through hole to allow for at least 3 connections to fit on there. So just be mindful of that when you're soldering the things together and the wire falls out from the bottom.
Yeah.
Just be sure to have those maybe bent, have the wire end bent so it like holds on
hooks into it. Yeah.
Yeah. Moving on to the LIS3H, that is going to be soldered in the exact same way. Just have the connections from the bottom, and then use a third helping hand to actually hold that over the M0 feather. So you can easily wire those together. The way that these are mounted is with this little 3D printed holder mount, whatever you want to call it, and it goes over the prototyping area on the feather. We're going to be using M2 4mm long screws. You want to make sure that they are indeed 4mm long so they don't protrude and touch any of the connections on the featherboard itself.
A word about the type of screw. You want to use the flat head, not the button or any other type, because the length are actually different for those types. So if you get a button type screw, the 4mm is actually 4mm thread. It doesn't include the head. These flat heads do include the head as the length of them. Plus they're better in terms of clearances, so they're not going to break any of the components that are close to the mounting hole. Just thought I'd say it.
Yeah, and the reason we're using the metal ones is because that's actually how we're creating the threads for all the 3D printed parts as well. The nylon tend to not do a good job of that.
They strip themselves there. Okay, moving on to the frame or spacer.
Yep, we'll just place those on top of the feather and use a longer M2 by 8mm long screws so that those will have enough room to reach into the spacer.
Yeah.
The spacer is actually fitted through the Charlie Plex wing. You can see in that.
You kind of thread it through.
Thread it through, and then the way that you actually align the boards is having the USB port being on the opposite side of where the chip is mounted on the Charlie Plex feather wing. And that's just because of the constraints with making the enclosure as slim as possible. Before you actually do that, though, you do want to make sure that you bundle your wires just so it makes it easier to arrange the wires once you put the LiPo battery between them. And we're just using a little strip of Kapton tape to hold those together. You can also use Noah's favorite technique, using the heat shrink wrap on that, but it's going to make it a little bit less bendable, which is why I went with this route. And after that, you only want to screw one side of the spacers on so you can have enough room to actually thread the JST connection to the battery through the little cutout that is on the spacer.
Yeah, this guy here.
Thread those through, and then you could attach the other two M2 by 8mm long screws onto that. Pretty simple to do, and then after those are joined together, you can go ahead and plug in your LiPo battery, turn it off if it turns on, and then you can move on to actually mounting it inside of the enclosure, which we're showing the wearable boxed version one here, but the standoffs and the general geometry that holds all of the components together is the same between the dome and the gimbal version of the enclosure.
Yep.
So you'll want to line those up. The main trick here is to make sure that the cutout for the display is in the correct orientation for the Charlie Plex wing. I actually wired those wrong twice, so just make sure that you're looking at the display cutout to make sure that those
mounted
are
it
right.
Twice.
Yeah,
it was wired right. Okay, and it looks like you're kind of using tweezers to line up the mounting holes so you can fully mount the assembly to, well, the main case, the main enclosure.
The last step is to attach the little cover that'll hide the screws on there. You can leave it off, but
it's like a half a millimeter thick, right? It's just pretty thin.
Yeah, it's pretty thin.
You could even decal it if you like, or something, if you have a vinyl cutter or something.
Yeah, that actually.
But it kind of gives it
cooler.
the benefit of, I can make this a different color. So really neat combination of colors.
I actually recommend
we're doing this for all our projects.
Yeah, I actually recommend printing the smaller lid for the dome, just so you have yet another little outline color for that. I really like the way that the color combinations for these are nice and vibrant.
Yep.
What else is left in the learning guide?
Yeah, we'll answer your questions in just a second. We're going to run through this guide here.
Oh yeah, mounting the slide switch to compensate for different tolerances of printers or filament. We recommend adding a little bit of tolerance to the slide switch by bending the two side metal clips on the side, by just bending them out just ever so slightly outward. That'll give it just enough tolerance so that it can easily snap into the slide switch mounts. You also want to position it in the middle position of the slide switch. If you jump over to the overhead, I can kind of show what I mean by that.
I was going to say insert it at an angle. No?
At an angle, and you want this slide switch to be like in the middle of on and off, so it can actually fit through the opening for this little switch because it's so small.
I think like the color changed and all sorts of things.
So just make sure that this is in the middle position before you try attempt to push this through the opening. Make it a lot more easier. Yeah, maybe this one.
There we go. It's the auto white balance on this lens. It's awful. And then I can turn this off to manual focusing.
Right about there into the middle. That'll help it push through.
Okay. Or use a file if it's too.
Yeah.
You got options.
And that should mount. The wearable version, you can stick the little pin. There's a little standoff, little walls for that to fit through. Okay. And that should snap in if you're building that version.
Oh, there's a wearable version. Did we mention that?
Well, I think we showed it last week. Yeah, but that one, when compared to the dome ones, were we didn't even shoot video of those because they were so cool.
Of the wearable version, yeah.
Yeah. And then the assembling the gimbal version, like I said earlier, they just the little points snap fit right into the nubs for that. Spikes, nubs,
snap into
pins,
the gimbal. Whatever. I mean the dimples.
And that's pretty much it. You can adjust the number of grains of sand, the brightness of that to have the battery last a little bit longer. But yeah, super addictive.
Okay, let me answer some questions here.
I have not been looking.
No, there's a lot of questions, so let's kind of scrub through them and learn and recite them. What's the diameter of the largest ring?
I put that in there. It's 51 millimeters for the radius.
51 millimeters for the radius? Or the diameter?
Diameter, what would that be? Double that?
Double that? Okay. Cool. Next question.
Diameter would be 102.
102, so it'll fit on a bed of 150 minimum. The lip is missing from the sidebar of parts.
Do you mean lipo?
The lipo? Maybe. I see it there.
I see it here. This is preview also.
No, it's there. It should be there. Try refreshing, Kirby, if that's what you meant. That was a question from Kirby.
I have noticed that not all of the products show up. So if you scroll all the way down in the overview page, I have them listed yet again. So if actually, I do not have it listed. There's two different spots on the sidebar and then down here, which I did not list.
Yeah, Kirby was saying the sidebar. Maybe he was saying that the reverse of that. Anyway, another question.
Which I am updating right now.
Okay, Paige is fixing that. Thank you, Kirby, for that one. DIY Engineering, David is asking, can we stack two Charlieplex matrices, or is there a limitation in addressing? No, you can do a couple different ones, and you can set the I2C address in the back, I believe, of the board. Check out the guide on the Charlieplex matrices. It'll give you all the information on how the limits or if there is one or not. Hey, what is this video about? the project. Yanni is saying it looks awesome. Thank you for the comment. Cajun and Yanni.
How do you switch between...
to use a commercial restream license or a free level? I think that we are using a commercial version.
Yeah.
Imagine adding sound to the... Oh, that would be really cool.
It would.
To add sound, yeah. There might not be room.
You know what? There might be room in the dome or the gimbal version.
Yeah, the weight.
There might be room.
There might be room to add a speaker. That was an excellent idea.
There is room in there,
that's really cool. Great idea, John.
Yeah.
How about inches?
That's what I'm trying to get to. How do you change millimeters to inches?
You just...
So if you go over to the overhead...
You use this guy, Spotlight. What is it?
It's 102...
2 millimeters to inches. That's 4 inches in diameter. 4.02 inches.
So if you jump over to the overhead, you can see the amount of spacer is available inside here.
Ooh, look at that.
Yeah. So the good thing to bring this up as well, the reason why this is all teetering and like unstable, which is perfect for this type of application, is because the screen for this is not mounted, or it's mounted off center, which is providing that teetering effect for that. You can kind of see it here.
Yep.
So there should be enough room for another board in here, and like you were saying, for the speaker, because this is solid, which is why we're able to print this with no support material. The only overhang is this tiny little part right here.
Yeah, about 1 millimeter of overhang.
Yeah, which if you have an active cooling fan, it should print out really good. And then we're just using the regular nub snap fit little model. John
is also asking if this was designed to be as small as possible. Do you think it's as small as possible?
I believe it is as small
without
as I
being
could.
Too
well, actually,
painful, because the smaller you go, of course, the as you saw Pedro,
it's right on the border.
Basically, is using tweezers to kind of get these little bits of wire in the right spot.
Which if you've been following for a while,
the tweezer
I
method
like making
is kind of nice, because I
like making everything as small as I can.
Wires can get hot if you hold on to it too long.
Oh, actually, it's so you can better position.
It is. It's absolutely for
dexterity with it.
Yeah.
So this is actually the smallest that you can get that into. I don't remember the size, but it is included in the Fusion 360 file, as well as the STLs on Thingiverse Imagine and pin shape for these. The one thing that I was surprised about was that the snap together lids worked on a circular geometry for all that.
Oh, hey, John Park's in the chat room. Hey, John.
Yo.
Thanks.
And again, you can play around with different film infill percentages. The one that we found worked the best was the 30%, just so that it has more weight.
So it's not solid as 100%. There is infill. So what the printer will do is make these cross hatches, and the more infill is just the more cross hatches, as John is asking. So it is not 100% infill, but it's pretty solid. I mean, 30% is pretty high if you look at the cross section of it.
It looks like 50%.
You could probably stand on it and it wouldn't break.
Oh yeah,
right, something like that. But you could just make it even more solid by doing. I actually told Pedro do 100%. He was like, "Nah, I don't think you need it," and it ended up working just fine without it.
Another thing that's attributing to the way that that it's teetering too is the layer lines for this. I think also messes with how it's rolling back and forth. So
yeah, I love the look
0.2 millimeter layer height seemed to be the best with that. And if it was any smoother, I don't know if it would do the randomness as
it gives you sort of this like sort of jerky look to it at some points. It looks like it's just like got its mind of its own. It's like it's got Parkinson's or something.
And then
shaky.
Is
it shaking there?
Yeah.
That's so nice.
For the gimbal.
Yeah, so this is the updated code where it's not so painstakingly bright, eye-blindingly bright. Very, very nice.
Yes, this was printed with PLA.
What about NinjaFlex so you can bounce it around the house?
That's a good idea.
That's a terrible idea. No, it might be a good idea.
I mean, it's inset so far in there that it, the NinjaFlex would protect it.
Could you kind of? What was I gonna have it?
Oh, have another stand on it.
No, just saying that like you can spin it and that sort of thing, so it feels like a hamster ball.
Yeah.
Hamster ball.
Is there a trick for
or
the
a
ratio?
for designing snap together parts, or does it just come from trial and error? Yeah, I mean, it starts with trial and error, and then you get this like, okay, I'm always going to use this sort of a gap, is what we like to call it. So there's always a little bit of gap between two facing geometry surfaces, whatever you want to call them. So what we tend to use is a 0.2 millimeter offset for whatever feature is going to snap into, let's say, an indent. Did you use the same for here? So it's 0.2, or is it is it more than that?
It's whatever you figured out the sizes for that was. Definitely check out the Fusion 360
It
files.
wasn't 0.2?
You can check out the sketches that are used to create all of these. It's literally just 2 boxes that are doing the extrusions for this. And when you're extruding at an angle too. I believe it's 35%. So it's actually doing the nice little like cheese wedge size.
Cheese wedge.
Yeah,
Ooh,
it's like a triangle or whatever.
What do you think? I also have a couple tutorials on how to create snap fit features for enclosures specifically. I think I have a few of them. I should probably do another one because it just keeps getting the features used to make the geometries is getting less and less every time. It's like, oh, I don't need to do it this way. I can, instead of using a chamfer, I could just do the tapered angle when I'm extruding, that sort of thing. So I'll probably revisit that. But there are some nice resources out there.
And we should probably...
Oh, there, yes. Stuart is saying, yeah, it's a good one. Thanks.
A good one to revisit, just because as we do it more and more, we figure out
especially with
ways
circular
to do it.
geometry. That's different, not too different, but it's worth doing it and just being like, well, here's how it looks like here.
Yeah.
Yeah, sure, no problem. Okay, so that is the project. Again, if you want to pick up any of the parts or some extra things that you might need, you can use coupon code GRAVITY and get gravitational.
Yeah. So circling back around to the LED cube one, yes, Lamar did see that one, and she's already cooking up plans to make.
Yeah, she said she's working on one, a bigger one. I don't know how. We do have LED panels; they're pretty big, so I don't know how we're gonna do it.
Yep.
Very
So,
cool.
Definitely stay tuned for that one.
Or if you just want to print this out, you know, this works
gimbal.
good on its own, just to spin it in your hand, and it's printed in place, so it's kind of magical.
And it doesn't need to be printed in place, but you can if you want.
Sweet.
Let's go ahead and jump into this week's
Shop talk.
prototyping. What are you prototyping?
Oh, sorry. I need to prototype a new voice.
Super
Because I'm
cool
missing it for some reason.
thermal camera you've been working on.
Yeah.
Lamar requested
Let me
a
give you
version
some context.
of these thermal cameras that have been popping up. Liz
And
made
Liz
one.
actually made the Raspberry Pi version, so she put one
Super
together
cool.
as well for the
Make sure
Raspberry
to-
Pi.
Make sure to check out her video on that.
Yes, please do. I'll link to it below. So yeah, this project is using the AMG 8833 grid eye thermal camera. And this is a nice little breakout that comes in different flavors. We have a feather wing version and this breakout version here. And I'm basically using the code for the Arduino. So we actually have an Arduino demo code. Most of our Adafruit components that comes with the library also comes with demo code. So you can make a project right away. And one of them is this thermal camera. So you can use a TFT display using our TFT display library for Arduino. You can use an Adafruit Metro, like in this case, or in our case, what we're going to do is we're using a feather. So that's what it looks like there. And then with a microcontroller with more processing power, like an ESP32, can double the resolution of the kind of 8x8 grid and give you more resolution. So it's pretty neat. So all the libraries, so you can make this right now is basically what I'm trying to say. However, the case is something I am putting together now. So this is the little case that I kind of came up with. It looks like a camera. I printed in these funky cool colors and put some stickers on it to kind of adorn it. The sensor is right in the middle of that camera lens, right there, this fake camera lens. And it's all multicolored and they're all printed in different pieces. The screen is in the back here. Got the on-off switch over here. Let's see if I can fix this autofocus crap. It's not focusing correctly. Maybe right there. And the frame rate's pretty good. There's 2 different versions of this. There's one for the feather wing and another one that uses interpolation. The interpolation one is the one that runs really fast. And I'm trying to get some good detail out of this. So bear with me while I mess with autofocusing. So there you can see it's kind of warm here. My hand's really, really warm. You can see my finger there. And there's the frame rate. It's pretty good. I'm wiggling my finger like a little worm. Or is it flame? I can't tell. Is it a flame or is it a finger? Oh, it's just my finger.
You see any heat coming out of that?
I see some heat coming off of that right there. It is ice cold now. It's pretty warm. Should get a see if my coffee is warm anymore.
Mine is cold.
Mine's probably cold. No, it's still warm. I'm not drinking it though because I know. So you can change the threshold, the minimum and maximum temperatures. They're in Celsius.
What? No, that's cold.
I know
man.
it's cold.
You can just change the threshold.
It's just really warm in this area. It gets really cold though. So that's basically kind of it. There's not much functionality to it other than kind of looking really cool as a thermal camera. So it is portable. It's using a battery. I'm really happy and thrilled with the case because it's kind of a different thing.
It's a new type of design.
This sort of snap fit with a little kind of, I don't know what you would call it, but I used the slot tool to make that. And there's like a accompanying nub here. So another type of snap thing. This frame is printed up on the Z, so it's not printed flat, and it gives you that curve here. So there's a little bit of a curve there, and some nice filleted edges. This thing here is printed flat, so this surface is printed flat on the bed, and then there's these little features that kind of slot into this whole frame, so you can take the whole thing out, and that's where the what do you call it? The sensor is mounted to. And the only thing that's keeping this together, these 4 screws for the display, the little standoffs there, and then the ESP32 feather is just mounts on there with headers, so it works really well. And I like the TFT display because it has 2 pairs of headers, so you can connect with male header pins up the connection. I could pop these out and switch out the board if I want, and then there's the battery. It's using a 500 milliamp battery, so it should be pretty good. Again, clips all together. You can print in different colors. I'm already starting to take photos of it and working on the guide because it's a pretty simple guide. It's more about the assembly. So yeah, that's the thing. I'll probably do a layer by layer on the case because I'm pretty happy with how I put together the case in CAD land. And that's kind of the project. Let me see if I can fix this again.
Joshua is saying that he tried the code to work on the ESP32 but couldn't get it.
There is an update, yeah, about a day ago.
Code
yeah, so the code for this, you can find it, like I said, on, maybe I didn't say it, but it is here on the, sorry, I had a brain fart. It's in the library for the AMG 8833. So here's the link. There's the library, or you can search for it manually in GitHub. Under the examples folder, it's going to be called ThermalCam Interpolate. That's the one. Again, the library was updated. And also try this one too. This was updated 6 days ago. It says fix 482. That was the latest update from Lamar. So you can try that out. And if that doesn't work,
you post it in the chat room?
Yeah, of course. The YouTube chat?
Mm-hmm.
Okay. There's the direct link to the GitHub repo. But I am using the Interpolate. There was a little fix made to the library for the AMG 88. So make sure you update your library and give that a shot. That should work. Cool.
And for anybody who wants to get a sneak peek of all of the codes that are being worked on for upcoming tutorials.
Yeah, learning guides. Yeah, there's a
GitHub right there that I just posted.
Right here. There's a lot of projects here. You can see which, I think you could sort it by days maybe, maybe not. Yeah, here's the breath mask from Mike Schuyler.
Mm-hmm.
He put that together recently.
Super cool.
Pretty cool stuff. But yeah, the LED sand, the Pagers project, this was up here for a couple weeks already.
About a month, yeah.
About a month,
mm-hmm. Yeah, these projects usually take about 3 weeks to film and design and all that stuff.
Correct. Okay, so yeah, pretty cool thermal camera.
Ooh.
I think it'd be cool to add a button and then like take a screenshot of the picture and save it to the SD card, because the TFT display already has an SD card and we have an SD card library. So that might be something to add to it. But I think for now this is going to be it. So there you go, thermal camera. Ooh, sweet. So if you want to pick up the thermal camera breakout, the AMG 8833. IR, grid eye, 8x8,
have all the project sensor, all the parts ready for next week.
Sure. Well, I can give you the files now if you want them. Okay, that is what we're prototyping. Now we're going to jump into shop talk. We are going to highlight one of the new tools that we're using to document our work. And
not that new, but you had some more thoughts on it since you've been using it for quite a while.
Yeah, I recently got them.
Right now.
No, I'm not wearing them. But Pedro is. And if you follow me on Instagram or Pedro on Instagram, you get a behind-the-scenes look of what we're doing with these things. We're using them to capture sort of the behind-the-scenes. So right after last week's show, I got myself some parts in the mail, as you tend to do for new projects. And I went ahead and put this together. So normally what I do is I just put the circuit together, put the prototype together, and I iterate, and sometimes I take a picture. But a lot of the times when I'm in the flow, I don't like to take out my phone and take a picture. It gets annoying. So with Snapchat glasses, spectacles, they're kind of just there. They're just kind of on your head. You click the little button and you start recording 10 seconds. Now, some folks might think that 10 seconds is enough, but it's definitely plenty to showcase in a string of an edit. You can really showcase sort of your story. So this is me putting this circuit together, and then the end of it is, hey, it's working here. So I sort of recommend it, but sort of don't. It's $130 for these pair of glasses, but you really want to be comfortable editing, offloading, that sort of thing.
I think that's the biggest barrier.
We use them heavily because we're editors by heart. We've always been video editors, and it's just something we like to do, you know. So if you fancy yourself to editing and capturing, but want to capture something and don't want to strap a GoPro to your head, this might be a viable option. There's a lot of different knockoff things coming out as well that kind of add on to your glasses. Maybe those are cool or not, but the quality from them is pretty well. It's like... it's HD. It's 1152 by 1152. It's a little bit weird. It does export as this kind of square look, so you can't, or the circle look, so you kind of can't get rid of it unless you zoom in, and crop into it, you know. But other than that, I'm starting to like them a lot, and I've been doing sort of these daily type vlogs where it's not really a vlog because there's no narration, but it's all visual, and I think sometimes storytelling visually without words is one of the best ways because it's universal. And there's me dropping header pins on the floor. So that's Snapchat.
Kirby says it's like the movie Final Cut, except it's not implanted in you. You don't have to die to watch the video.
That's fun.
And John is asking, we got clear lenses? Yes, we got clear prescription lenses, actually. And you can get them non-prescription, but I definitely recommend getting the transition or the photochromatic one so that you can use them as regular lenses when you're indoors. Then when you step outside with the UV light, they'll turn it into sunglasses.
Yeah, chromatic. Yeah, can you show them over the overhead, please? We want to. John is asking, how do you take a video? How do you trigger the video? And stuff?
The video is triggered by this button on the left side here.
So there's a big button there.
It does 10 seconds. If you double click, it'll do 20, and if you triple click, it'll do 30 seconds.
Correct.
And the batteries last about, I want to say, 20 to 30 clips each.
Yeah. So that on the side here is a grid of LEDs, and when you double tap it, it gives you a battery indicator, so you know how much battery you have. It also is an indicator to let people know you're recording. So you want to record real quick, just to show you what happens. So the ring it starts spinning, and that is sort of to let other people know that you are filming them, just as a curiosity or as a courtesy thing. But there are stickers where you can hide it if you want. And then the camera itself is actually right here. It's not over there. It's right here. Yeah. So.
And then a quick demonstration of showing the transition or the photochromatic stuff with UV light when it hits it. They turn into sunglasses.
Yeah, they double as sunglasses. How good.
So definitely recommended for that. I think that is one of the missteps that Snap actually did. They should have included or partnered up with Transitions or whoever makes photochromatic lenses and had those included, so they're not so difficult to use as sunglasses.
At first, I didn't like the frame. I didn't like the look. I was like, I don't like that look. They feel comfy. They feel a little heavy on my head, but I've grown to like them, so they work well.
And they're super easy to pop out.
Yeah, so charging is interesting. It has like the case that it comes with actually charges. You put it on the case and it starts charging there with these little contact points. It's never failed. It's really good. The battery capacity in that case is fairly well. You can charge it maybe like 5 times on it. And it lasts throughout the whole day, which is pretty interesting. You can get about like, I don't know, 50 clips. It's a lot of clips.
Yeah. I think usually like on trips or whatever, I get about 80 clips. And again, the barrier is actually
it might not be for
all
you
that.
guys. PT is a good example of like, I needed this to just work and kind of record longer than 10 seconds. It didn't work out because there's just a lot of time that you have to go into editing to put together a cohesive
That's where
edit.
most of the time is spent.
If you want to edit. You don't have to, but just throwing it out there. So cool. That's our little segment on Snapchat spectacles, using them in work. And that's it. Yeah, it also comes with a charging cable. That's correct. That is correct. It's pretty nice. It's a pretty nice piece of tech.
Next up is this week's Time-lapse Tuesday. Super awesome bomb from
Chaos
Garrett.
Core Tech. Yeah, Garrett, who better known as Chaos Core Tech, designed this in Fusion 360 originally as a single part, and then he remixed it so that it can be printed in multiple materials. So we figured we'd try this out. If you haven't seen it yet, check it out here right now. Here's a time lapse. Oh, it didn't start from the beginning. Yeah, so people were asking, surprised that now because I'm using wood filament, that's a composite PLA type filament that has actual wood fibers mixed in with the PLA plastic to make this kind of wood-like material. It tends to be a little bit stringy, a little bit difficult to print with in certain circumstances, but meaning it tends to ooze a lot because it's just like
a lot of cleanup
comes out, and I didn't have the settings correctly set for it. But it ended up working fine because I cleaned it up, and people were surprised how well it cleaned up.
I was surprised. I thought we were gonna throw this model away.
No, as you can
so
see, there's a little bit of contamination, and there's a lot of string. Very easy to clean up with Haku flush diagonal cutters, which we actually carry them in the shop. So if you're looking for a nice tool, you don't have one yet, definitely recommend getting them. They're these little flush diagonal cutters that work really well on all sorts of different things. I've seemed to have misplaced them. There they are. They're really nice.
Andy is asking, we printed this with no purge block? Yes, this is actually why we wanted to print these on the Ultimaker 3, because everybody got so mad with the Mosaic purge blocks. The Prusa does the same thing as well.
Yeah.
So we wanted to mitigate that.
Yeah, so this was zero waste. There's zero waste here.
Absolutely no waste. There's no
a little bit of cleanup, but that's easy to do.
No ooze shields, no...
Correct.
The Ultimaker 3, like when we first got it, it did have to use purge towers or a shell, like
a new shield.
But
they've made it pretty well where the firmar just knows how to cool it down, and that's why it takes like what 11 hours to print or something.
Yeah, because it goes over the side, it retracts, it cools the other extruder or nozzle, so it doesn't print core, or whatever they want to call it. They cool that down, and then it moves over and starts printing, so there isn't any or as much contamination.
Yeah. But as we've said, the wood filament just loves to ooze. I'm supposed to print with it a little bit less hotter in terms of temperature because it likes to ooze. But anyway, filmed all this stuff with the slider, which was last week's project. If you're curious, I'm going to keep using it. But let's take a look at the surface detail a little bit more, just to look at how well it cleaned up here. Let's see if I can turn off the autofocus.
Again, this is a 0.2 millimeter layer height. I think it was printing at 215 or 220, which we should have lowered down for the wood fill down to like 210, just so it doesn't ooze as much. And as with the past projects, if you change the temperature on this, you can get different colors on it. So you can get like this pretty cool striation, or like wood, that wood texture that is on real wood. Yeah. And there is no ugly side to this. Usually with doing dual extrusion,
the seam is kind of noticeable right here. There's the seam. This is where the loop kind of joins, the outer perimeters join at this seam here. So you can kind of see it there. But it's not bad. It's a little rough, but it doesn't feel too bad. Yeah, and I just use these guys to clean it up. These are the Hako flush diagonal cutters. So I just kind of went through there and cleaned it up. So that's it. Surprisingly printed pretty well for wood filament, because wood filament's a little, it likes to under extrude sometimes. It likes to ooze a lot. And there's probably the ugly side there. You can see there's a little bit of a nick there on the nearest leg. But hey, it just adds that rustic charm. So there you go. Huge shout out to Garrett. You can download this model on Thingiverse. Search for Bob or Chaos Core Tech, and you can find it here.
Super cool.
And I posted it as a make there, so you can check it out. There's a lot of different colors. Look at this one in red. It looks really nice. So give Garrett a shout out and a subscribe on YouTube. I'll link his stuff below.
There is also a tip button as well on his page.
Yep, and you can order it as a print if you'd like it as well.
Stuart Riggs is asking, how do we turn off purge block inside of Cura for the Ultimaker 3? Do you have Cura open?
I could open it. I didn't even know. I turned it off. I think I just had it on default.
I think they removed that. Or maybe I just have it hidden.
Yeah, maybe update Cura. Maybe it's an older version. It should be under the dual extrusion setting. It's still trying to open on you. I'm using Cura 3.1.0. And if you take a look here, I'll do a screen capture here so you can see my whole screen. And if we step through the material down, there is a dual extrusion part.
And it's one checkbox.
It's gone. Enable prime tower, which is not checked.
Disable it.
And then if you click on that little gear icon, you can get all the settings. Wipe inactive nozzle on prime tower.
I'm sure there's specific
shield distance
situations where you would still need a prime tower, but they've done a really good job of updating their firmware and their software to not really need it for most situations.
Correct. So try and take a look in there. Again, the little gear is only hot. It only reveals itself after you've hovered over the segment here. And we're in the custom tab. So if you're in recommended, you got to switch to the custom tab and then scroll down until you find it. Cool. Hopefully that works. If not, we can reach out on Twitter. We'll talk back and forth. And that's pretty much the shop talk and a little bit of the community makes. But we're kind of running out of time, so...
Oh, yeah, let's go ahead and jump into, if you guys have any questions for this week on any of the projects. John K. had a question on any tips and how often do we clean our printers?
We clean it until there's a problem.
Yeah. So the biggest thing is...
the nozzle cleaning, right? So how do you clean the
nozzle?
nozzle?
The nozzle or the gears on the extruder?
The feeder, right?
The feeder,
where it's pulling that filament in, it tends to grind. You switch it out quite a bit. It gets the teeth in the timing pulley or whatever you want to call it. It's time to get gummed up, so you kind of clean it out every so often.
With the extruder, we heat it up to like 250 and then insert nylon to do a cold pull with that, which means you let the temperature drop to, I believe it's like 120 or 130. Wait for that to cool, and then you, with a pair of pliers, you pull out the nylon filament, and that'll take with it any clogs that are inside of the nozzle. I'll do that every, I don't know, like 2 weeks, depending on if there's any problems that are showing up with extrusion.
Okay.
Other stuff, just the 101 stuff, like just cleaning up around your bed. So
yeah, if you're using a heated bed with glass, I highly recommend always wiping it down with a little bit of alcohol and like a paper towel, just to keep any grease or dust off that, so that the stick is really nice. And if you have a PEI sheet, well, you don't need to do anything, right, Kirby? The PEI, like
they last a while, yeah.
The best ever.
If you're using blue tape,
no one makes better builds than PEI. No one. Anyway, that was fun. Where we're we gonna jump to? Any other questions? Yeah, we'll look through them. But hey, let's take a look at the community makes. I want to check out the cool stuff in Discord chat room. This is where we're gonna find all the stuff on show and tells. So if you want to share your projects, you want to get on the show, post it up in the show and tell channel.
Kirby's saying 2,000 grit sandpaper on PEI. That'll get the
brings it right back to new. Yeah. Wow.
Alcohol on PEI, says Stuart.
Yeah. Yeah. All right, back to the Discord. Here we go.
Oh, John was asking, John K was asking about the frames, the snap frames. No, they only come in this.
They only come in one frame. One size fits.
One of the projects that PT had was to hack these into something else, but I don't think the popularity, it was after all the financials had come out for Snap, so we don't think it's.
Oh yeah,
I don't know if it'll be popular or not.
They're in a little bit of a bind here. Yeah. 100,000 of them sold, unsold units sitting in a warehouse. Oh no. I hope the price goes down. Anyway, let's take a look at Discord, shall we? All right. First project, first show and tell is from Enrico or Incio. It looks like some graphics. Star OS.
Oh, cool.
Okay. That's good stuff. Russ is sharing something in a different direction with AdaBox 02. A balancing bot. What? There's a balancing bot done with AdaBot 02. That is amazing. Check this out. Look, it's balancing with a circuit playground, really? Wait, no, it's probably not a circuit playground. It's probably something else. I figured that somehow it was circuit playground now. Each AdaBox has a different board. Sweet. That was awesome. We also have Azure Skies with some progress to... Is that a tiny whoop? Or is it a little bit bigger than a tiny whoop? It's a drone. Looks like a DIY drone. Carbon fiber body. That's cool. Sweet. Oh, this is amazing. We did a quick quick project.
This
NeoPixels
awesome.
And a trinket. The Lego Saturn V kit. We're still trying to get this kit for ourselves. We really want to build this.
Mostly we haven't got it because every time we show up at the Lego store, because I want that discount, I want those VIP points, they're always sold out.
Yeah.
So don't send me links to eBay or whatever.
Oh, that's great.
I want to buy them in the store.
So excellent.
But yeah, the way this turned out.
I love the photos here. I love the documentary. I love how clean Medium is. Very, very cool. Huge shout out to Cat.
So freaking cool.
I love it. Oh, it's just a CNC machine. No big deal. Awesome. Look at that. That keeps it upright. That is great. So cool.
Because of this, I'm totally going to use this as an excuse.
It's like a shrine. It's like this wall is dedicated for the Saturn rocket.
Totally going to use this as an excuse to turn this into a
native project.
Yeah.
we're gonna do this. Sorry, but we'll shout you out. All right, great.
I mean, it's so popular they can't keep it in stock. So
yeah, it is. So we'll never have it.
Might be good.
Give it a rocket.
So freaking cool.
Okie dokie. Let's keep scrolling down here. See if there's any other projects that people want us to share. Sigafos has some work in progress, desoldering through whole components. And that's it. This week is pretty clean and pretty digestible. A couple tips and stuff. Always a great place. It looks like Liz is helping Danny out with some resources for learning how to solder.
Oh, awesome.
The real question is it solder or solder? The world may never know. The world's divided by people who say... There are only two types of people. People who say solder and people who say solder. All right, guys. Well, thank you so much for joining us. It's been a lot of fun. I'm going to start recording this camera thing. Mm-hmm. And we'll be here next week. Till later tonight, we'll probably be on the show and tell. If not, because we're not too tired. It's just we want other people to be in our spot. Mm-hmm. So we want more people to be on there. So if you'd like to be on there, you can join by going to the Discord chat room and just hanging out on YouTube. We'll drop the link there. It's on tonight at 8 p.m. Eastern Time. 7:30 p.m. Eastern Time. And then followed by that is a full hour of Lamar and Phil. New products, Raspberry Pi, Arduino, open source stuff. And one last thing I forgot, huge shout out to Naomi Wu, who is going to be on the cover of Make magazine issue number 61. Very cool. Awesome. Very, very long time coming.
Mm-hmm. Much deserved.
Much deserved. There you go. That's the right word. Cool. Also, tomorrow, John Park's workshop. He's back.
Cooking up some really cool projects.
Yep. As always.
I think it might have to do with those pocket MIDI.
You think so?
Maybe.
Yeah. Playing around with some cool pocket operators. Cool. Well, that is all we got. And yeah, there's John Park. If you want to sneak peek anything, yeah. If you want to sneak peek anything, now it's time to do it, John. He's cooking right now. That's great. Don't forget, Coupon Code Gravity expires tonight at 11:59 p.m. Oh, thank you, Don. We watch your show every morning. It's like it's like a ritual.
Right before we start the rehearsal for the show.
Yeah. Gotta make sure we get that in. Cool. So check out Don's Maker Project Lab, because there aren't many people doing that, and I really appreciate that.
Yeah.
Really, it's good work.
Tips on the flexible sandpaper this week.
It's a good mix of content. All right. Well, thank you guys so much for joining us. We'll see you next week. Till then, good luck with all your Maker projects, and I wish I had a better closer.
See you guys.
Bye, everybody.